All right, so yesterday we were taking, the basic y equals x squared. We were moving it to the right, moving it up. We were reflecting it upside down so the parabola went down. You guys have some experience with this, right? And so it's just a matter of bringing it back in our memory how this stuff works. So there's a vertical shift that we took advantage of yesterday by just adding a certain amount. K is the amount that we're going to add to the y value. So let's put down a little example like y equals x squared plus 3. That's going to take our parabola over here and it's going to move it up 3 spots. So it's going to look like this, right? You're probably ahead of me. So we've got this parabola that's doing something like that. You got to pay attention to, we went over 1, up 1. That's what the basic y equals x squared does, right? Because when you square 1, you get 1. When you square 2, you get 4. So some of the problems today in your homework, you're going to have to pay attention to, like, is it, also vertically stretched, which we haven't got to yet. But, like, if I come over 1, I should be at 4, right? So over 1, up 1 is going to take me to 4. Horizontal shift is harder to understand. Like if you had f of x, they usually say it like this, x minus h. So when you've got that like an x minus h here, they often do minus h because it's the opposite of what you would expect. So an example of that would be like y equals x plus, I don't know. So let's just keep with a 3 for a second. Y equals x plus 3 squared is going to look like, we're going to shift the parabola left 3 spots. So it's going to be over here, and it's I may have made this one look a little bit skinnier, but as soon as I label my axes here, like this is -3, and if I come over 1 spot to -2, I want to try to show that it's just, going up still 1. It's not been vertically stretched or anything like that. So this is the basic parent function that's been moved to the left, right? So now let's talk about vertical stretches. Well, if all of these things like f of x minus h or f of x stands for the y value, if I put a number in front, like some constant a, so I've had a of f of x, that would be a vertical stretch, right? So an example of that would be something like y equals 3x squared. So now, let me push it way out here so that it doesn't get mixed up with the one above it. Now what we have going on, and it's hard to, like, if I drew this thing super skinny, it might be hard for me to label my axes. So I might make it look kind of like almost the same as the one up above. I'm trying to make it look a little bit skinnier. But if I went over 1 in the x direction and I figured out what the y value would be, it would be 3. Instead of it being over 1, up 1, it's over 1, up 3. It's 3 times whatever the original one was doing. So if I came over to 2, oh geez, this is going to be hard to put on here because it's kind of like, it's like way up here, right? If I went over to 2, that was, before that was at 4, right? If I go over 2, I go up to 4. So I want 3 times that amount, and I'd be up at 12 up here, right? So this would be a y value of 12 because, everything's 3 times. If we made a little table out here and we went, okay, x is 1, and then we said, okay, what is 3x squared? Well, that's 3, right? And then what is it when we plug 2 in? Well, I plug 2 in, I get 4. 4 times 3 is 12. So I hope I'm making this clear. Do you see how the y value is 3 times what it was before, times 3? Okay, I think those are probably the easiest ones. The horizontal stretch and compression, you can't tell the difference by just looking at a parabola, whether it's been vertically stretched or horizontally stretched sometimes. So this part starts getting a little confusing, and I hope they don't have a lot of these, honestly. But what you'll often see in a textbook is you'll see f of b of x. And I don't know, I didn't probably mean to put parentheses around that. Let me get rid of my parentheses there for a second here. You'll see something like f of bx. And when you have a multiplier inside, everything's happening sooner than it normally would happen. So let me jump over to Desmos and show you what I'm talking about, okay? It's much quicker and easier to show if we just have this to look at, okay? So let's say we had f of x equals x squared, right? Okay, so I go x squared. Now watch, when I put a 3 in front, look how it looks like it gets skinnier, right? See how it looks like it gets skinnier? Well, because I went over 1 and I've gone up 3 now. So that's pretty easy to understand. Now watch this. If I go inside the parentheses and I put a 3 here, it's going to compress or horizontally stretch. I mean, it looks like a vertical compression, but it's going to horizontally stretch this. Watch this. Oh, I mean, it's going to horizontally compress it. Or vertically stretch it, and that's really kind of weird because watch this. When I put 1/3 in there, that makes it look wider, which is like a vertical compression, but this is actually a horizontal stretch. So it's so weird how this works. The way I think about it is it's going to take x 3 times bigger than what we had before to generate the same y value. So it's like we're going out 3 times further. See, if I go out to 3, then I go up to 1, right? It used to be that I'd go out to 2 before I'd go up to 4, up here at 4. So now I'm going to have to go out 3 times as far. So I was going out 2, I'd have to go out to 6, I think. Let's see if that's true. See, at 6, I'm at 4. I've gone out 3 times further than I normally would have had gone out. So it's kind of weird, but this is a horizontal stretch or compression, really I should say, or compression here, depending on what we got going on. And this is a vertical stretch or compression, depending on what kind of number we have. Now, see here, let me try to explain this. When we have a number greater than 3, it's a vertical stretch. When we have a number greater than 1, it's a vertical stretch. When we have a number less than 1 but greater than 0, it's a compression. Where when it talks about horizontal stuff, did you notice if I had a 1/3 in here, that's actually a horizontal stretch. So it's kind of weird. When b is less than 1, boy, this pen really messes with me. Then we have a stretch, meaning our parabola is getting kind of wider. If we have b greater than 1, we have a compression, horizontal compression, which is really the opposite of what's going on up here. When b is greater than 1, we have a vertical stretch. When b is less than 1, we have a vertical compression. So I don't know. I mean, what you want to put down here? I would say you put down y equals 3x squared, like we had in our drawing over there on Desmos. And let's try putting down, a wider parabola like that. Okay, draw it right through the function. And go out here to 6 or something like that, and then make that 4. See, it would have been happening at 2, but now it's been 3 times stretched out, right? What would have happened at 1 is now happening at 3. Okay, so at 3 we got a 1. That's really hard to tell because, like, this looks like a compression, vertical compression, right? Here's a better function to look at. Instead of the quadratic to look at, it might be better to look at the sine function, which we haven't had any kind of major exposure to. And that's why compressions horizontally are kind of unfair. So this is what the basic parent function looks like. If I put a 3 in front, do you see how it vertically stretches everything, makes everything further away from the x-axis? Now, if I put the 3 inside, it doesn't do anything at all like that. It compresses it, it shrinks it down, right? So let me go back over here and look, make sure I put that in there right. Oh my goodness, I put a 3 in there, and I meant to put a 1/3 in there. Could you fix that for me? I don't want to have to redo my whole video. So remember how we had like with the x squared, let's go back to the x squared for a second. And if we had a 1/3 in here, then it it made everything wider because we had to go out 3 times as far, right? So I meant to say 1/3 in there when I was putting these numbers down. Oh boy. All right. Hey, the reflections are pretty easy to understand. If you have a opposite of f of x, the opposite of f of x, that's reflecting it over the x-axis. So like if we had y equals negative x squared, right, that's going to take and reflect it upside down, make it go like that, right? If you want to reflect it over the y-axis, with a parabola, you're not going to be able to tell the difference because it's symmetric about the y-axis, with the basic parent function, that is. So maybe the better thing to do would be to do a little bit of a reflection or a translation first, but really we're saying f of negative x is going to reflect it over the y-axis. So like if I had y equals negative x, okay, let's see, how should we do this? Let's put it like this, negative x plus 3, and let's go over and we're going to look at what that looks like on Desmos, okay? So if I come over here and I put in here negative, see inside the parentheses that are going to get squared, I put a negative right there, open parenthesis, and then I put x plus 3, all right? So the plus 3 is speeding everything up, right? So it's moving it 3 to the left. But see how you can't really see the negative in here because it is still symmetric about this vertical axis. So, you know, the reflection over the y-axis with the symmetry function is kind of awkward, right? Man, I hope I'm making this clear. We've got these transformations we need to manage. We're going to see homework problems today that look like this. You have to identify which function we're dealing with. Well, you can see it's been reflected upside down. So we're looking for something like this, negative, right? Now you might want to pay attention to, is it going over 1, down 1? It is. So this is the basic parent function that's been reflected, and then it's been vertically shifted up, right? So B is the right answer for number 7. If we look at one that looks like a little bit skinnier, see how this one looks a little bit skinnier? How we go over 1 and we go up 2 right there. So now we're looking for something with a vertical stretch. So you see this guy right here has a vertical stretch on it. So pay attention to those kind of details as you're doing today's homework. Hey, sorry I talked so long. I hope that makes sense. Thanks for watching my video.